Larynx 3D model. Respiration is an essential component to voice production. The exhalation that takes place during the respiratory cycle for voice production is what drives vocal fold production. The necessary conditions and sufficient condition for phonation. We have laryngeal abduction, the arytenoids pull together so vocal folds together in the pyramidal position, medial compression of the vocal fold with longitudinal tension, have to reach enough subglottic pressure to cause the vocal folds to be blown apart. The production of subglottal pressure where respiration is essential. So the respiratory component is that during exhalation muscle of exhalation, an elastic recoil forces of the lungs cause a decrease in the volume of the thoracic cavity, which drives up pressure. That's how we generate pressure. Muscle of exhalation, an elastic recoil forces in the thoracic cavity in the diaphragm, returning back to its original resting position. Decrease in volume of cavity results in increase in pressure until we reach phonatory threshold. Intrinsic muscles. Set of adductors, lateral cricoarytenoid and interarytenoid. Intrinsic muscles. Adductors, interarytenoid, transverse, and oblique fibers of the muscle cause the arytenoids to come together and slide across the cricoid cartilage, are rotated together to and so the vocal processes are bring the vocal folds together. Lateral cricoarytenoid pull on the muscle process on an anterior and inferior, causing a rocking and rotation of the arytenoid cartilages so the vocal processes are brought together. The vocal tensor are pars recta and pars oblique fibers of the cricothyroid are the primary mediator of pitch, causes a decrease in the distance between the thyroid and cricoid cartilage, which stresses the vocal folds, causing an increase in pitch. Thyroid arytenoid muscle, vocalis, forms the body of the vocal folds. Thyroarytenoid muscularis attaches to the muscle process, then to the lateral vocalis. How the cartilages move. The interarytenoid muscle, the lateral cricoarytenoid, pull forward and down on the muscle process, rotating the vocal process in. Cricothyroid causes the thyroid cartilage to rock forward, increasing distance between anterior and posterior attachment of the vocal fold. Vagus supplies everything laryngeal and all intrinsic muscles, except for the cricothyroid to the larynx, receive nerve supply from the recurrent laryngeal nerve. The cricothyroid is supplied by superior laryngeal. Myoelastic aerodynamic theory of phonation states that once the necessary conditions for phonation are achieved, adduction, medial compression, longitudinal tension, subglottal pressure has reached phonatory threshold, phonation begins, with the phonatory threshold causing the vocal folds to part. Air rushes through the glottal space. When that happens, the Bernoulli effect on the vocal folds is such that there is an increase of velocity of airflow through the glottis, while there is a decrease in pressure against the sides of the constriction vocal folds. When there is a drop in pressure against the sides of the vocal folds, with the decrease in pressure, the vocal folds are no longer held open and they are sucked back together. Subglottal pressure will build back up, blow the vocal folds apart, pressure will drop and they'll get sucked back together, and so on, 100 or so times per second. The mucosa wave is the movement pattern of the vocal folds during phonation, inferior to superior.